welcome to the first ever Wizard Skate tournament. I'm so excited. I'm so excited. We spent so long working on this game and it's finally ready to be released to the public. You know, we have our beautiful competitors here behind the camera. Hold on. Yeah. Here we go. Yup. Yeah! So let's get to it. Let's get to our introductions and let's get to the game. What's up, guys? I'm the host, Angel Amaya, and I made the sprites go onto the screen. So I know the intricacies of these hitboxes. I know the little details, and I will win this competition.
I'm Nalquasm. I made the scores, so I know how it works. I know how to optimize my scores.
Hey, I'm Roger Brown, and I think I'm gonna do a really good job in this tournament. I'm the one who designed the RNG system and the fireball system, so I know exactly when the fireballs are coming and how they're coming, so I'm gonna be able to avoid them.
My name is Luke McCarthy, and I think I have a very good chance of winning this match, this tournament, because I'm the one who built the collision code. So I know exactly how it works, I know its intricacies, and I think I'm gonna do pretty good.
Okay.
That's unnecessary. Okay. Let's go, Roger.
All right. Here we go.
Let's go, Roger! Oh, we should have designed.
Master Wizards. Roger, is your depression going?
Yeah. I feel like my life finally has purpose.
Okay, we should write down the scores next to the names.
Oh.
Oh, 1825.
All right.
Okay. Oh.
Cheering sound effects.
Oh my god.
What did you get?
You're like 70. You're like 70.
It's my time to shine.
That's so exciting. Okay.
Oh.
At least the collision works in that one.
Oh my god.
No,
Why did you do
It
that?
was like 320.
The bar is
It's
really
pretty low.
low.
It's pretty low.
It just beat 70. Go past the first one.
Let's go.
Oh, okay, whatever. You still on. Okay, Roger.
So Roger, how are you feeling about the tourney today and your competition?
I'm extremely focused.
Roger's almost about to break 1,000. Oh, there he goes.
Here he's incorrect.
You see,
about my
since this game is actually built in the source engine,
of course.
the D-hopping is an option. I learned that story.
Oh,
That was 1703.
1703.
What?
Yeah, so for the final, we decided to have the whole panel come and watch the game with the gamer themselves to add some commentary, of course.
Currently at 300, no sweat.
That surpassed both me and Angel's first scores.
Very sensitive topics. Wait, hold on.
Risky strats, risky
Wait, hold on.
That
Wait.
RNG can ruin you,
The
but he
odds-
knows how to handle it.
The odds have. Can we get? Let me call it Sports Kings right now. What are the updated odds of the
DraftKings?
Sports
Kings? Yeah, those
The
guys.
Game of the Year award.
Game of the year.
Oh my God! Wait.
No! Why did you? No!
Was it 17? We need to
We need to run it
replay.
back. We need to run it back.
Okay, guys. So we're gonna be reviewing the play because it was so close. All right. So let's take a look. VAR.
Oh my god. Right there. Let's see. 1735.
Damn.
No, that means Roger won.
Wait. No!
1703.
He deserves it, honestly. Oh yeah, I can't curse. Oops. I mean, he got me. He deserves it. He was working hard. He put in the work, and you know what? I'm happy for him. I'm glad.
Let's go. I'm awesome. No, you suck.
That's right. On Sportsman Mike. Yeah.
Beautiful.
All right, so I worked on a good deal of this project, like different parts of the code, but the two most important things that I worked on and made good was probably the game controller, which is the top level module in the collision controller. So I'm gonna do a quick rundown of each. So in the game controller, the most important thing about this is handling I/O and handling some top level variables that you pass around, like if a collision has been detected, if a reset has been detected, and also organizing the different functions or the different modules into a very easy to find, easy to read way, so anyone that comes into the code can like track variables, see exactly where they're going, and understand what's going on. And the collision controller is pretty much just one giant conditional. It has some inputs and a single output, which is if a collision has been detected. And the inputs are just like the wizard offset, the fireball offsets, all that kind of stuff. And I did my best to make this conditional, easy to read by segmenting it out and giving helpful comments for each line to know what's going on. And that's it for my part.
So this is what I did for the project and the game. So this is the score count for VGA module. It takes in 3 inputs, the frame, the collision, and the reset, and outputs the BCD score as well as the regular score value. So this always block is the BCD converter. So basically what it does is it takes the score value and it shifts the bits to the left. And by doing that, you're effectively doubling the value of that bit. And if the value is greater than 4, it adds 3. So since you're shifting, that's basically adding 6. And then allows a maximum value of 9 to be displayed. And then this always block is just the score counter. So every other frame, it increments score by 1. And if there's a reset and a collision, then the score is reset back to 0, so you can play the game again. And then for the VGA controller, the part that I contributed was this part. So these are just the pixel values for each number to be displayed. So you got 0 through 9. And then this is the actual score display. So there's 4 values, the thousands place, the hundreds place, tens place, and ones place. And this basically just displays each BCD value in the top left corner.
And that means I spent a lot of my time in the VGA controller module. So let's get started and break this down as to how this works. Basically, the way that image processing is handled in Verilog is that they use 12-bit color depth. And so this is why every register here is assigned for 12 bits. And then basically what these values here represent are the size of the image. So for example, the game over screen was 320 by 240, and that multiplied together is 76,800, and so on for the other sprites that are 16 by 16, they obviously add up or multiply to 256. So the way that Verilog read the images was basically by using the readmem-h, because we had hex files that had all the hex values for each pixel of each sprite, and we loaded those into a one-dimensional array. So if we scroll down here, the way that we get that one-dimensional array is essentially by locating the top leftmost point and multiplying it by the length of the sprite. So through that, we're able to index into the array and be able to find the according pixel values. So for example, the first 16 values of the hex file is the first row of the sprite. So we get that index, and then we assign those colors, with the first 4 bits being red, the second 4 bits being green, and the last 4 bits being blue, into the VGA R, G, and B values. And that is how we got image generation to work for color sprites.
Hi, I'm Roger, and I'm going to be going over the RNG and Fireball controller modules. For the RNG module, it's very simple. It just multiplies 2 numbers together. Those 2 numbers are seed, which increments once every clock cycle, and hold, which will become equal to seed when the user presses the space button. This is important that there is user-generated randomness, so that every time the game is played, it is a different experience. The Fireball controller module sets the X and Y offsets of the 2 fireballs that are on screen. You can see here that there's a case statement that uses the random number generated in the RNG in order to set the initial X and Y offsets of the fireballs. At the bottom, as long as a collision has not been detected, the fireball X offsets are incremented by 5 plus this extra variable faster, which is determined by the score. So every time the score increases by 300 points, faster becomes incremented by 1, which adds a progressive difficulty to the game. And then you can see whenever the game is reset, the X offsets are reset to 0, as well as whenever the X offsets are greater than 700, which would be off of the left side of the screen, they are also reset to 0, so that they can get new initial conditions and come through again.